Get ready for a fascinating conversation with one of the brightest minds in history, Albert Einstein. The physicist who revolutionized our understanding of the universe, responsible for the theory of relativity and the famous equation E equals mc squared, goes beyond formulas and numbers. In this interview, Einstein reveals his more human and intimate side, talking about his curious childhood, school challenges, passions, political convictions, and even his views on life and death. Was he as organized as we might expect? And what does he have to say about the rumors surrounding his love life? Don't miss this rare opportunity to hear, in a simple and engaging way, the thoughts and reflections of the man who changed the course of science. Stay with us and discover who Albert Einstein was behind the genius. Hello, Doctor. Albert Einstein, it's an honor to have you here with us. I would like to thank you. It's truly a privilege for us.
Thank you for the opportunity to be here. Talking about my discoveries always excites me.
Let's start by talking about the beginning of your life. Were you always a curious child?
Yes, I was always very curious. I remember when my father gave me a compass when I was 5 years old. I was fascinated by the fact that the needle always pointed north, even though nothing was touching it. That made me realize that there were invisible forces in the world, which sparked my interest in science.
Tell us about your father, your family. Can you tell us a little about your childhood?
Of course. My father, Hermann Einstein, was a businessman and engineer. He ran a small electrochemical factory. My mother, Pauline, was a very intelligent and cultured woman, and she was the one who introduced me to music, which became a passion throughout my life. I grew up in a middle-class Jewish family in Ulm, Germany. Although we weren't religious, family culture and values were very important. I had a younger sister, Maya, with whom I was always close. I remember that, despite some financial difficulties we faced, my parents always encouraged me to learn and explore my curiosity. They were quite liberal when it came to education, which gave me the freedom to question and think independently. One of the memorable moments of my childhood was when my family moved to Munich. There, my father and my uncle Jacob opened a factory for electrical equipment, and that's when I started becoming interested in science, especially electricity, which my uncle explained to me in a fascinating way. My childhood was a time of discoveries, but also some social difficulties. I never felt very comfortable at school, and that reflected in my more introspective behavior. But overall, my family was a great pillar in the development of my scientific curiosity and my passion for learning.
In school, did you already show signs of being a genius? Is that why you had difficulties interacting with other children?
Actually, I wasn't considered a genius in school, quite the opposite. I had some difficulties at first. I was a different kind of student. I always preferred to think independently, and the educational system of the time, which valued memorization and repetition, didn't suit my way of learning. This made me appear slow or uninterested, especially to some teachers. However, from an early age, I already showed a deep curiosity for more profound questions, which somewhat distanced me from the common interests of other children. I had a certain disdain for rigid rules and authority, which also contributed to my socialization problems. In primary school, I was a bit introverted, and would often isolate myself to think or read. This may have given the impression that I didn't interact well with others. What truly fascinated me was mathematics and physics, but the school didn't offer many opportunities to explore these subjects creatively. I always felt that the school system stifled me a bit, so I preferred to study those subjects on my own at home. With my family's support, I nurtured my love for science. So, my social interaction difficulties weren't because I was a genius, but perhaps because my way of thinking and my interests were a bit different from the children around me. And that often made me feel out of place.
Is it true that your intelligence quotient is much higher than most of us? Have you ever reflected on that?
The question of intelligence quotient, or IQ, is something that gained more relevance after my time. During my life, I never worried about that kind of measurement, and honestly, I was never tested to know what my IQ would be. The concept of intelligence is much broader than a number can express. I've always believed that what's important is curiosity, imagination, and persistence in seeking answers. Many people consider me intelligent, but my view was always different. What led me to my discoveries wasn't an innate ability, but a constant curiosity and determination to question what seemed obvious. I always sought to understand the world around me in a deeper way. That, to me, is more important than any IQ score. I've reflected a lot on what it means to be intelligent. To me, intelligence is linked to the ability to question, the humility to accept that we don't know everything, and the passion to explore the unknown. In my opinion, the value of intelligence lies in how we use our minds to contribute to humanity and expand knowledge, not in how it's measured in standardized tests.
You and your family moved several times. How did those moves impact your childhood?
During my childhood, my family moved several times for economic reasons. My father had difficulties with his business, so we left Ulm, where I was born, for Munich when I was still very young. Later, when I was 15, we moved to Italy after my family's business faced bankruptcy. I briefly stayed in Munich to finish my studies, but I soon followed them to Italy. These childhood moves, especially going to Italy, gave me a broader view of the world. I think they helped me see things from an international perspective early on, which later reflected in my adult life when I became an advocate for pacifism and human rights on a global scale.
So during the Nazi regime, you were no longer living in Germany?
Exactly. When the Nazi regime came to power in 1933, I was no longer living in Germany. In fact, I had left the country the year before, in 1932, for a series of academic trips across Europe and the United States. When Hitler took power, I was in the United States, giving lectures and attending conferences. As soon as I realized the gravity of the situation in Germany and the rise of Nazism, I decided not to return. The persecution of Jews and intellectuals escalated quickly, and the Nazi government confiscated my home and belongings. They even put my name on a list of enemies of the regime. In response, I officially renounced my German citizenship and never set foot in the country again while Hitler was in power. It was painful to see Germany, where I had built much of my scientific career, transform under a regime of hatred and violence. I ended up settling in the United States, where I found refuge. There, I was welcomed by the academic community at Princeton, which allowed me to continue my work in a safe environment. However, it was always sad to think about what was happening in Europe, and how many friends and colleagues stayed behind and suffered under the regime. Leaving Germany for good was a rupture that deeply affected me. Germany was where I had made my most important discoveries and where I had many personal and professional ties. Abandoning all that because of intolerance and hatred was painful but necessary to survive and continue my work.
Changing the subject, can you tell us what motivated you to pursue a career in physics?
My passion for understanding how the universe works. Physics provided me with the tools to explore the great mysteries of nature. I wanted to understand the fundamental laws that govern everything.
One of your most famous works is the theory of relativity. Can you explain it to a layperson like me, who avoided physics classes?
Of course, I'll try to explain it simply. The theory of relativity may seem complicated at first, but its essence is quite accessible. I'll divide it into two parts: special relativity and general relativity. Special relativity, which I published in 1905, deals with how space and time behave for objects in motion, especially at very high speeds, close to the speed of light. The main idea is that time and space are not absolute, meaning they aren't the same for everyone, as was previously thought. They change depending on the speed of the observer. A simple example: if you were on a train, traveling at a speed close to the speed of light, time would pass more slowly for you than for someone standing still at the train station. This is called time dilation. Another important point of this theory is that nothing can travel faster than light. Now, general relativity, which I published in 1915, goes a bit further. This theory explains gravity in a new and surprising way. Before, we thought gravity was a force that pulled objects together, like the Earth pulling an apple down from a tree. But what I discovered was that gravity is actually a curvature in the fabric of space and time. Imagine space-time as a trampoline. If you place a bowling ball in the center of the trampoline, it sinks and deforms the surface. Now, if you roll a smaller ball near the bowling ball, it will follow the curved path around it, as if it's being pulled. That's what gravity does. Massive objects, like planets and stars, curve the space-time around them, and that's what causes other objects to move toward them. So, general relativity tells us that what we feel as gravity is actually the effect of this space-time curvature. That's why planets like Earth orbit the Sun. They follow the curved path created by the Sun's enormous mass. It might sound complicated, I know, but I hope this image of the trampoline helps to visualize it better. The theory of relativity completely changed our understanding of the universe, showing that space, time, and gravity are all interconnected in ways we hadn't imagined before.
Yes, I think I learned more from you in one answer than I did all year in school. Thank you. To complete my understanding, can you explain the famous equation E equals mc squared?
I'm very happy that my explanation helped. Now let's talk about the famous equation E equals mc2, E equals mc2, E equals mc2, which is probably one of the most well-known in the world, but sometimes misunderstood. I'll try to explain it simply. This equation is part of my special theory of relativity, and it describes the relationship between energy E and mass, m. What it tells us is that mass and energy are in fact two forms of the same thing, and they can be converted into each other. Let's break down the equation. E is energy. M is mass. C is the speed of light in a vacuum, which is a very high constant, approximately 300,000 kilometers per second. C2 means the speed of light is squared, making the value incredibly large. What this equation shows is that a small amount of mass can be converted into a huge amount of energy, because the speed of light squared is such an enormous number. For example, if you could completely convert the mass of a tiny object, like a grain of sand, into energy, you would get a colossal amount of energy. A practical example of this is what happens in nuclear reactions, like in atomic bombs or nuclear reactors. In these reactions, a small fraction of an atom's mass is converted into a massive amount of energy, and that's what makes these explosions so powerful. In essence, E equals mc2, E equals mc2 shows us that mass and energy are not completely separate things, as we used to think. They are interchangeable. That is, matter can be transformed into energy, and theoretically, energy can also be transformed into matter. This equation helped revolutionize our understanding of the universe, from the reactions that happen in stars like the Sun to the functioning of nuclear energy. And the most incredible part is that all of this is embedded in such a simple and elegant equation. I hope that helps clarify the power and significance of this little formula.
Are you enjoying the interview? Don't forget to leave a like. This will strengthen the channel, helping us bring more content like this. You published a series of papers in 1905, known as your Annus Mirabilis, or Miracle Year. Can you tell us a little about that?
In 1905, I published 4 papers that revolutionized physics. Besides special relativity, I wrote about the photoelectric effect, which later earned me the Nobel Prize, and about Brownian motion, which helped prove the existence of atoms. It was a very productive year.
You won the Nobel Prize in Physics in 1921, but not for the theory of relativity. Why?
That's correct. I won the Nobel for my work on the photoelectric effect. The theory of relativity was quite controversial at the time, and the members of the committee preferred to award something more experimental. However, the photoelectric effect helped lay the foundations for quantum mechanics.
Many people are surprised to learn that you had a significant influence on quantum mechanics.
My contribution to quantum mechanics began earlier, with a paper I published in 1905, the same year I introduced special relativity. In that paper, I explained the photoelectric effect. And that's what really connected me to quantum mechanics. The photoelectric effect describes how certain materials emit electrons when exposed to light. At the time, classical physics couldn't explain this phenomenon. What I did was suggest that light isn't just a wave, as it was believed, but can also be made up of small particles or packets of energy, which we now call photons. This idea helped lay the groundwork for quantum theory, which studies the behavior of subatomic particles. Quantum mechanics, in turn, deals with the behavior of very small particles, like electrons and photons, on microscopic scales. It's based on probabilities and uncertainties, something I personally never felt comfortable with.
God does not play dice with the universe. Does this famous quote express your thoughts on the matter?
What I meant is that I believe the universe is governed by clear and precise laws. I don't like the idea that chance plays a fundamental role in nature. Quantum mechanics suggests there's uncertainty in the behavior of particles, but I've always felt that this wasn't the complete picture.
With all the discoveries today, how do you evaluate the advances related to quantum mechanics?
The advances in quantum mechanics since my time are truly impressive. Although I had reservations about some aspects of the theory, I recognize that it has been extremely successful in describing the behavior of the subatomic world and in opening doors to technologies that have transformed society. In my time, quantum mechanics was still in its early stages. I contributed to this field, especially with my work on the photoelectric effect, but I was never comfortable with the idea that particle behavior was governed by probabilities and uncertainties. My view was always that the universe should follow clear and deterministic laws, which is why I criticized the probabilistic nature of quantum mechanics, summarized by Heisenberg's famous uncertainty principle. I believed that, deep down, there was a more fundamental explanation that we hadn't yet discovered. That said, the advances in quantum mechanics would surprise and, in a way, fascinate me. The development of technologies like quantum computers, which take advantage of the principles of superposition and quantum entanglement to perform calculations with a speed and efficiency unimaginable in my time, is fascinating. There's also quantum cryptography, which promises secure communications based on the laws of physics, something that was once unthinkable. Quantum entanglement, a phenomenon that disturbed me greatly, and which I famously called spooky action at a distance, has not only been experimentally confirmed, but it is now fundamental in fields like quantum computing and information science. The idea that two particles can remain connected regardless of the distance between them is still a challenging concept, but modern experiments have confirmed this behavior in an undeniable way. However, despite all the progress, there are still fundamental questions left unanswered. The unification between general relativity, which describes gravity and the universe on a large scale, and quantum mechanics, which describes the subatomic world, remains one of physics' greatest challenges. This fascinates me, as these two theories, while successful in their respective fields, don't naturally integrate with one another. What we call quantum gravity, or a theory of everything, is still out of reach, but scientists continue to work on connecting these two pillars of physics. So I would say that despite my initial criticisms, the advances in quantum mechanics are extraordinary. They reveal that the universe is far stranger and more complex than I could have imagined, and modern scientists are expanding our understanding of the fundamental laws of nature in ways that, in my time, would have seemed like science fiction.
During World War II, you played an important role in the development of the atomic bomb, correct?
Yes, although my involvement was indirect. I signed a letter, along with physicist Leo Szilard, warning President Roosevelt about the potential of German nuclear research and the possibility of an atomic weapon. This led to the Manhattan Project. But I was a pacifist, and the use of the bomb was something that caused me great sadness.
Do you regret writing that letter?
Yes. After seeing the devastation caused by the bombs in Hiroshima and Nagasaki, I was deeply shaken. I never imagined that science, which should bring progress, would be used for such destruction.
We know you were a pacifist. How did you deal with the political tensions of your time?
It was complicated. I always stood for peace and human rights, but I lived through a period marked by wars and authoritarian regimes. I fled Germany because of Nazism and spent most of my life in the United States, where I continued fighting for peace.
You were a member of the National Association for the Advancement of Colored People, NAACP, and fought against racism.
Yes, that's true. I've always had a very clear stance against racism, and my participation in the NAACP was one way of expressing that conviction. When I moved to the United States in 1933, I was deeply shocked by the racism I witnessed, especially against the African American community. To me, the racial discrimination I saw in the United States somewhat mirrored the persecution Jews faced in Europe under the Nazi regime. This touched me personally. I had the privilege of meeting and becoming close to important civil rights leaders, like W.E.B. Du Bois and Paul Robeson, who were influential figures in the NAACP. I admired their work greatly, and I did what I could to support the cause, both publicly and financially. I firmly believe that there can be no true peace as long as discrimination and injustice exist against any group of people. In my view, racism is one of the worst forms of ignorance, a moral failure that needs to be fought by all those who defend human rights. One of my most memorable moments was when I accepted the invitation to give a lecture at Lincoln University, one of the first African-American universities in the United States. I was moved by the warm reception and by the strength of the young students who were determined to fight for their rights. I also made sure to publicly support Marian Anderson, a great African-American singer, when she was prevented from performing in certain places because of her skin color. I invited her to perform at my home because I found it intolerable that someone should be judged by their color and not by their talent or character. For me, the fight against racism wasn't just a political issue, but an ethical one. I believe that all of us, as human beings, have the responsibility to ensure that no one is judged or treated as inferior because of their race, ethnicity, or religion. This was one of my strongest convictions, and I did what I could to support equality and justice wherever I lived.
Besides physics, what else interested you?
I had many interests. I loved music, especially playing the violin. Music was always a source of relaxation for me. I was also deeply concerned with social issues, like civil rights and equality.
There are rumors about your relationships with women. Is it true? After all, you were married.
Yes, this is a delicate issue, and I understand the curiosity around it. During my life, especially after becoming a public figure, many personal aspects were widely discussed. Indeed, my love life was complicated at times, and there were matters that affect how people view me today. I was married twice. My first marriage was to Mileva Maric, a fellow physicist. We had 2 sons, Hans Albert and Eduard, and before we were married, we had a daughter, Liesel, about whom little is known. Our marriage faced difficulties, especially due to my intense dedication to work. Over time, our relationship deteriorated, and we divorced in 1919. Shortly after the divorce with Mileva, I married my cousin Albert Einstein, with whom I had already been close, even during the later years of my first marriage. Elsa was a great companion and gave me much support, especially during my move to the United States and the pressures I faced as a public figure. As for the rumors about extramarital relationships, there is some truth to them. Throughout my life, I had relationships with other women, even while I was married. Personal letters that surfaced later revealed that I corresponded with several women, and these relationships certainly brought complications to my marriages. I wasn't a perfect man in this regard, and I admit that I didn't follow conventional standards of marital conduct. However, it's important to remember that these personal matters don't define my contribution to science and thought. I was a human being with flaws and contradictions like everyone else. My life was often marked by difficult choices and an imbalance between my work, my intellectual passions, and my personal life. While these aspects of my personal life may be of interest, I hope people remember more what I sought to achieve for the progress of science and the pursuit of a deeper understanding of the universe.
Do you believe intuition plays an important role in science?
Absolutely. Intuition is essential, especially when dealing with concepts that challenge understanding. However, intuition needs to be tested and confirmed by rigorous experimentation.
Just out of curiosity, were you very organized with your work?
No, actually, I was quite disorganized. My desk was always full of papers and books, but I knew where everything was. I believe chaos can coexist with creativity.
Is there any myth about your life that you would like to clarify?
Many people think I failed in mathematics when I was young, but that's not true. I was always good at math. What really frustrated me were subjects that required memorization without understanding, like history.
In your opinion, what has been science's greatest contribution to humanity?
Many people think I failed in mathematics when I was young, but that's not true. I was always good at math. What really frustrated me were subjects that required memorization without understanding, like history.
What do you think about the future of physics?
I believe there are still many mysteries to be solved, especially in the attempt to unify quantum mechanics and general relativity. I'm hopeful that future generations of scientists will be able to achieve a unified theory.
What was the greatest challenge you faced in your career?
The greatest challenge was balancing my desire to understand the universe with the resistance of some fellow scientists to my ideas. Science is a pursuit of truth, and that's not always easy or quick.
Do you think there is intelligent life beyond Earth?
It's a fascinating question. The universe is vast, and it would be presumptuous to say that we are the only ones.
You are one of the brightest minds in history, and are also very much admired for your peaceful personality. Can you tell us what you consider your most important contributions to humanity, from your own perspective?
Thank you for your kind words. When I look back on my life and the impact of my contributions, I would say that, beyond any recognition, what I truly sought was a deeper understanding of the universe and the role of science in advancing humanity. But if I had to highlight some of my most important contributions, first and foremost, the theory of relativity. It profoundly changed our understanding of time, space, and gravity, with both special and general relativity. Additionally, my work on the photoelectric effect, which earned me the Nobel Prize in Physics in 1921, had a deep impact on the evolution of quantum mechanics. I published hundreds of books and articles. Beyond my individual work, I also collaborated with other scientists on various projects, including Bose-Einstein statistics, the Einstein refrigerator, and more. Another important aspect, which is very dear to me, was my activism for peace and human rights. From a young age, I was a pacifist, and throughout my life, I used my voice to promote disarmament and international cooperation. When Nazism began to spread across Europe, I realized the need to warn people about the dangers of a regime that promoted hatred and destruction. Later, after understanding the devastating power of nuclear weapons, I felt morally obligated to fight for peace and the control of these technologies. I always believed that scientific knowledge should be used to improve people's lives, not to cause destruction. My fight against racism was also an important part of my legacy. I believe that my involvement with the NAACP and my support for civil rights leaders like W.E.B. Du Bois and Paul Robeson were social contributions that reflect my belief that every form of injustice must be fought. In summary, I see my greatest contributions not only in science, but also in the realm of ethics and social justice.
When we interviewed Leonardo da Vinci, he told us that he had always been a curious and observant person. It seems this quality surrounds brilliant minds.
I'm glad to hear that Leonardo da Vinci shared that view, and without a doubt, he was one of humanity's great geniuses. I believe curiosity is one of the most fundamental characteristics of any brilliant mind, whether in science, art, or any field of knowledge. For me, curiosity was always the driving force behind my discoveries and my desire to understand the universe. Since childhood, I was fascinated by simple but profound things, like a compass, for example, which made me wonder why the needle always pointed north. This led me to think about invisible forces that govern the world, and later, this same curiosity led me to question concepts like time, space, and gravity. Curiosity makes us look at the world with fresh eyes, questioning what is often accepted as absolute truth. It leads us to observe details that others might overlook, and to ask questions no one has yet thought of. Like Da Vinci, I was a keen observer of nature, and this ability to see the world in a unique and inquisitive way allows us to make connections that others don't see. I often say, I have no special talents, I'm only passionately curious. It's this constant pursuit of the why that led me to make my discoveries. At its core, I think curiosity is the flame that lights the path of creativity and progress. Like Da Vinci, I believe this quality is one of the pillars that sustain brilliance in any field. The ability to marvel at what is simple and to question what seems complex is what keeps the mind alive and active. And that, I believe, is what defines a brilliant mind.
You were wise throughout your life, and even when you learned of your health problems, you faced death with detachment, despite leaving so much behind.
I appreciate your kind words. When I learned about the health issues I was facing in my later years, including the aneurysm that eventually led to my death, I truly approached the end of my life with detachment. I never feared death. I saw it as something natural, part of the cycle of life that we all must go through. I've always believed that what matters is not how long we live, but how we use that time to contribute to something greater than ourselves. I once said, "I want to go when I want. It's tasteless to prolong life artificially. I've done my share, it's time to go. I will do it elegantly." And that's truly how I felt. I knew that the science and knowledge I had helped build would continue to evolve without me. We are all just small parts of something much larger, a vast and mysterious universe that will continue to exist long after we are gone. My view on life and death was always influenced by a certain serenity. I believe my ability to accept death is tied to my way of seeing the universe. We are part of a much larger whole, governed by laws that transcend our immediate understanding. When you have this perspective, it's easier to accept the fact that we are merely passengers on this cosmic journey. What matters to me is the legacy we leave behind. I don't just mean scientific discoveries, but also our actions, ideas, and the values we pass on. I knew that, when I departed, my work would be in good hands, with future generations of scientists, thinkers, and ordinary people who continue to question, explore, and create. So when I learned that my health was failing, I chose not to fight it. Life, with all its wonders, had already given me more than I could have asked for. I was ready to leave the stage and let others continue the journey. For me, death is not a tragic end, but simply a natural part of our existence.
Thank you very much for the interview, Dr. Einstein. It was a pleasure to hear your inspiring words. To wrap up, could you leave us with a brief message?
The pleasure was all mine. I'm happy to have shared some of my reflections with you. If I could leave one message, it would be this. Never stop questioning. Curiosity is what moves us forward, helps us learn, and allows us to understand the world in new and profound ways. Humanity's progress depends on our ability to think beyond what we already know, to explore the unknown, and to face challenges with courage. Remember, as I once said, imagination is more important than knowledge. Knowledge is limited to what we've already discovered, while imagination has no limits. It leads us to new possibilities, new ideas that can transform the future. And finally, never forget the importance of kindness and justice. What truly makes life worth living is how we treat one another. And that's what will allow us to build a better world for everyone. Thank you very much, and always move forward with curiosity, courage, and compassion.
I hope you enjoyed the interview. Please leave a like and follow Resenha Historica for more content like this.